All right, we're going to go over number 54 in our textbook, which is the heat 2 of our big tricycle race. So in the second heat, it's Elizabeth, Kay, and Hannah who are racing down the track. They knew the winner would compete against the winner from yesterday. So let's talk about K's. When the line representing K's race is graphed, the equation is f of x equals 2 divided by 3x plus 1. What was her speed in meters per second, which we know is our unit rate, right? Per means that 1 second. And then did she get a head start? So I remember that this part, whatever is in front of my x, is my slope. And this is my starting point. So our slope is 2 meters. That is her rise. And her run will be 3 seconds. So if I want that in terms of the unit rate, I'm going to combine this guy here, this 2 divided by 3 meters per second. And that is our speed. And then her head start, since it is a plus 1, yes, she got a 1 meter head start. Now let's talk about Elizabeth. Elizabeth's race is given by this equation, f of x equals 12 divided by 16x plus 4. Who is writing faster, Elizabeth or Kay? Well, the easiest way to compare the speed of these two racers is from their unit rate. So let's find Elizabeth's unit rate. So we have a 12 meters for every 16 seconds Elizabeth is riding, which I can write as 12 over 16, but I know I can simplify that as well. Both of these for sure can divide by 2. So I'm going to divide the top to get 6 and the bottom to get 8, but it looks like they can divide by 2 again. So I'm going to do that again. And I will get 3 over 4. And I can't simplify that any further, so I can go ahead and write meters per second. So I'm trying to figure out, is 2 divided by 3 bigger, or is 3 divided by 4? If you want to change these to decimals, you can definitely do that. That might be a little bit easier to compare. So if we do 2 divided by 3, we get 0.67. And I'm just going to write myself a note here that this is equal to 0.667. And then 3 divided by 4 is equal to 0.75. Well, 0.75 is definitely bigger than 0.67. So we're going to say that Elizabeth is faster because 0.75 is greater than K's 0.667. All right, so part C here, we want the unit rate, which we know from our last problem will end up being meters per second. Also from the last problem, we got our unit rate after we were given the slope. Now we're not given the slope here, but we can definitely find it. So if we recall, slope is equal to rise over run, and it's also the change in y over the change in x. So I'm going to focus on this guy here, since I think that this one is easier with a graph. So let's talk about the change of y's. So our time is x, our distance is y. So how much am I changing from this y to this y? Well, if I do 14 minus 10, I get a change of 4. And let's double check, just make sure that is the same change is happening both times. So 18 minus 14, I also have a change of 4. So I'm going to say my change of y is equal to 4. Now let's do the same thing with x. What is our difference? What is our change of x? 28 minus 14 is equal to 14. Is it the same here? Let's find out. 42 minus 28 is also equal to 14. So we can say that our change of x is equal to 14. So now let's put it into our slope form. Change in y over change in x is equal to 4 over 14. And if we add in our units, that is 4 meters every 14 seconds. Well, we want it every single second, right? Our unit rate is per second. So I'm going to take this fraction, and you can change it into a decimal just like we did before, or you can leave it as a fraction. So 4 divided by 14 gets us a decimal of 0.285, which I'm going to round to 0.29 meters per second. All right, to entertain the crowd, a clown rode this tricycle for this equation. Without graphing or making a table, describe the clown's ride. So we know that y equals mx plus b is our normal equation. Now y is very similar to f of x. There are just two different ways to name your equation. So I'm going to rewrite the clown's tricycle ride so that it matches the way that this guy's written, which means my x comes first. A negative x plus 20. Now, if there's no number written in front of this x, it is an invisible 1. That will always be true for anything in front of a variable. If it's not written, it is an invisible 1. So, negative 1 meters per, and there's nothing underneath it, which also you could say there's an invisible 1 under it. So per 1 second. Now, if he's going negative meters, we can deduce that that means he's actually writing backwards. At a unit rate of 1 meter per second. Now this plus 20 is our other piece, which we know is our starting point. So, but he starts at 20 meters. So here is a nice full description of how the clown is riding his tricycle.